So the range is one of the easiest ways to measure variability. And what it is it's the difference of the largest and the smallest value in your data set. Here you see the largest value is 715. Here the smallest value is 525. If you subtract those, you get a value of 190, which is the difference of that. So you would have a range of 190. Variance and standard deviation are going to be your most common measures of consistency in business applications, particularly in the area of quality control. In quality control settings, businesses prefer a smaller standard deviation, which is an indication of more consistency in the process. And so, with variance, this is a measure of variability that uses all of the data. It's based on the difference between the value of each observation and the mean for the sample or the population. And variance is useful in comparing the variability of two or more variables. And so you're going to take the average of the square deviations between each data value and the mean. So this is an example of the variance of a sample, and this is an example of the variance of a population. With standard deviation, we are going to look at the standard deviation of a data set is the positive square root of the variance. So this is measured in the same units as the data, making it a lot more easily interpreted than variance. And this is what standard deviation of a sample looks like as compared to the population. Now, with coefficient variation, or sometimes you see it as CV, this measures a distribution standard deviation in terms of its percentage of the mean. A high coefficient variation is going to be an indication of high variability or less consistency. Comparing consistency between two data sets when their means are very different is best done with the coefficient of variation. When comparing two samples, the smaller the coefficient variation, this is an indication of more consistency in the sample population. I'm not going to have you work a coefficient variation problem, but I do want you to know that this is used when comparing the consistency of two data sets when the means are very different. I want you to know when it's used, but I'm not going to ask you to do the formula. So looking at the distribution shape and its location and how to detect outliers, we're going to be using z-scores for this and also the empirical rule. So these two things we are going to be looking at more closely. So a z-score, and I do have a video posted, I believe that's on standard deviation. I can't remember if it's standard deviation. I believe it's standard deviation. But we're going to be doing a lot with z-scores. We're going to do these in this chapter, but also when we get to chapter 6. But the z-score is often called our standardized value. And the z-score tells us how many standard deviations data is from our mean. And an observation z-score is a measure of the relative location of the observation in the data set. If the data is greater than the mean, the z-score is greater than 0, it is going to be positive. And if the data value is equal to the sample mean, it's going to be 0. If the data value is less than the sample mean, the z-score is going to be negative. So your formula for z is going to be your value x minus your mean over your standard deviation. And so here you have x, which is 525, minus your mean apartment score of 590.80 over your standard deviation of 5474, and you get a negative 1.20z. And what that means is this is less, if it's negative, your mean is going to be here. These are your positive values, these are your negative values. So it's approximately 1 standard deviation below the mean. So it would fall right here somewhere on a normal distribution. And we're going to be looking at this more closely. Another example would be, and you are going to be learning to interpret it, but here you have the caloric value of hamburgers in fast food. And you're looking at how far is 1230 from the sample mean of Burger King. So Burger King, you had, if you're looking at the Z-score, you've got Burger King's hamburger is 1,230 calories minus the mean caloric burger of 788.4 over the standard deviation. And you get positive 1.23. So what does that mean? Well, it means if your mean is in the middle, that it's going to fall right here on our normal distribution because it's greater than the mean. If you're looking at the empirical rule, and you do need to learn this, the empirical rule states that 68% are going to fall within positive and negative 1 standard deviations of the mean. Here, 95% are going to fall positive and negative 2 standard deviations, and 99.7% are going to fall positive and negative 3 standard deviations of the mean. If they fall outside of positive or negative 3, or positive or negative 3 or greater, we call these outliers. Outliers are extreme events. Now, with Chebyshev theorem, I'm not going to do a whole lot with that other than I want you to know that it's a mathematical rule similar to the empirical rule, except it applies to any distribution that is not symmetrical. So this is for not symmetrical distributions. This is what is symmetrical, okay? This is your typical bell shape. This is symmetrical. But if it is not symmetrical, you are going to use Chebyshev's theorem. And I'm not going to get into a lot of this other than you just need to know Chebyshev's theorem is for not symmetrical distributions. Here you're looking at more explanation for the empirical rule. Do learn this with the 3 standard deviation to 1 standard deviation. Outlier is anything positive or negative 3 standard deviations. Okay.